This lecture is about functional programming, and as a tool, we will use Java 8. Okay, so a little background. Okay, when my journey with Java 8 and functional began a few years ago, and I heard about it there and here, and read some books and blogs and stuff. And then we came to the point in our project when we decided to move to Java 8. It was 4 months ago. It was a very nice decision, very good timing. We did some refactoring the code, so we made it, and we are very happy with that. And a few months ago, I was in a DevOps conference, which is in Belgium. A very good conference, Java conference, biggest in Europe, something like Java 1 but for Europe. And I heard about a lot about functional programming in Java 8, so on. It's a big step for Java, and I was really inspired about the topic, and I felt like a lot of things came together for me, and just like to organize it and to share it with you. Actually, this is the background of this presentation. So let's get started. Okay. So, in this presentation, just to set expectation, I will focus on what functional programming is. Okay, this is not the. I will not talk about Java 8 as a feature list. Okay, my main goal will be to explain what functional programming is. Okay, the theory and the concept. Why functional? I put it as a primary question in this talk. Okay, so why it is good. Why to move, why think functional. And Java 8, we will use it as a tool, okay? Probably most of you using Java, that's why you are here, but let's think about it as a tool and not like a functional language. Maybe it's not, maybe it is, maybe it's not, but let's try to think what functional is and why, and Java 8 is a tool, okay? So a lot of features in Java 8 will not be here, and this is not the point. If you have any questions about it, maybe I will have time to answer, but don't expect to full Java 8 list and so on, okay? Generally about questions, if you want to ask any question, please just raise your hand. If you want to ask in Russian, it's okay, I will translate. Hebrew, the same. C++, Java, all works, so no problem. Okay. Sorry? Louder? Okay, I'll try. Now it's good? Okay. So, functional programming. What it is, okay? In computer science, functional programming is a programming paradigm, a style of blah, 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 blah. It's a lot of words. So, let's try to focus what it is. It's about functions, okay? So, when we start thinking about functional programming, it's about functions. We start thinking of it as a building block, as a first-class citizen of our program, okay? It's about avoiding mutable data, okay? What it means that mutable data, it's data in our program that we can change, okay? If we can change data, we can get in troubles when you do multi-threading, right? So functional programming is about trying to avoid mutable data and to try to use only immutable data, okay? To simplify actually our multi-threading. It's about declarative. So when we think functional, we think about declarative style. So we probably used to think like loops and things like that. And declarative style is like, okay, I just want to do this and that. I don't expect to tell how I do it. Okay, we will see it in details further. And about expressions. So in functions, we sometimes use expressions in order to implement logic, okay? Why functional? As I said earlier, it's a main question I want to answer here today, so let's focus on it. It's less code, it's expressive code, it's correct code, it's fun, and it's in performance. Okay, performance I will talk, it's with the start, I will talk later. So today we will try to prove this, okay? Why it's less code. We probably all agree that it's good things, okay? but why it's less code, why, how we can achieve expressive code, why functional programming, it's more correct code. It's fun, I will talk about it also, and about performance. Sometimes it's better, sometimes it's not, but we will talk about it, okay? So we'll come back to this question a couple of times. Let's start from building blocks. Before we go to some detailed concepts, let's start from some building blocks in Java 8. Function. Function reference, Lambda, predefined Java functions, and stream API. Okay, so we will start from function. I will use just the code. Okay. So in Java 8, the function is defined by just defining an interface with one and single method, which is abstract. Okay, this is the definition of function in Java 8. The functional interface annotation is just a helper to help a compiler to help us. For example, if I will do something like void do again, the compile will yelling, yeah, it's not good, it's not a functional interface because we have two functions. Okay, but if I remove the functional interface annotation, it's still function in Java 8. Okay, so how can you use function in Java? As you know, it's just I can define an object, okay, and just call it. That's all. This is the simplest way to use it. We have different ways to use it, but this is the simplest way to use function. Function reference, it's actually maybe the most important thing that Java 8 brings. Okay, we have function. We have function which is static right now. Okay, and call it. This is what we used to. Okay, but I can do something more interesting. I could do something like that. What means that the basic function I defined later, before, okay, is actually instantiated by this pure function. Okay, but pure fun is actually static function. Okay, so this is actually the reference. Here, yeah. This is basic the usage of referencing a function. Okay, so once I defined an interface, and I defined another function, maybe static, maybe not, I can connect them, and this is the connection. Okay.
Where is the connection?
Here it is. Okay, so I defined it as an interface, right? Okay, and here I instantiated it by the reference. This is very interesting. This is something very new. Okay. So before, okay, as we saw before, I had to write code like that, right? I need to make new class, maybe anonymous class, and only then I can use it, right? So in the new world, I can do something like that.
So anything with one method can override it.
I can define another function here, okay, like static, public, and use it. Okay, so no problem with that. Okay, so this is very important in Java 8 because this simplifies our code and makes it more expressive, and we will see how many things, different interesting things we can do with that feature. Okay. Okay. Higher order function. It's basically a function that accepts another function. Again, this is definition on theory definition, yeah, of what functional terms. But I just show you in Java 8. So if I define something like that, I have a function, right, that accepts another function. So we call it higher order function, that's all. Okay. And of course we can use it by code like that. So for example, I define here do it twice, and I accept basic function, and just do it twice. Okay. So in main I can instantiate basic function with my pure fun. I can instantiate another function by referring do it twice, and just combine it. Okay, hide on a function, do with something basic fun. Okay, so actually what it will do, it will run the pure function twice. Okay, let's run it. So we already see some kind of combinations with functions. I can get function and use it and so on. I can pass behavior like that. Okay, here. Okay. Let's just summarize what we saw. So this is the basic function definition in Java 8. This is the basic usage. Function reference, I can define any function, static or not, and can instantiate it by reference with double dot dot. Okay. Okay, yeah. So higher order function is a function that gets another function. Here the example, and here how I use it. And this is some kind of diagram. Okay, if I get pure function into as input to do it twice, I got pure fun twice. Okay. Another important thing in Java 8 is just a kind of set of predefined functions objects that will help us, okay, to manipulate functions. And we will go over it a little bit. Okay. So this is the important package, Java util function, and I start with function, which is one of the primary interfaces, which is actually generics, and it accepts T, which may be everything, and returns R, which also may be everything. Okay, and just predefine function in order we can use it. We can define by ourselves, nothing special here. Okay, and let's go over. Okay. Okay. So another interesting, there is a lot of different tools like that. Another interesting thing is predicate. It's just like a function, but it returns always Boolean. Okay, predicate, it's well-known term. It's of a function that returns Boolean. Okay, and accepts anything. Where it is useful, if we want to filter something, we want to filter by some predicate. Okay. Supplier is also a function, but it accepts nothing. Okay, and consumer, it's just vice versa. It accepts anything but returns nothing. So and so on. So a kind of tool set of building blocks. Okay. So we went over it. We have by function, which we can accept 2 parameters and return one result. Okay, Lambda. Lambda is another interesting thing in Java 8. It allows me to define function without name of a function. Okay, for example, like here. Basic fun is the same definition we saw already. I can do like that. So it's like accept nothing and just print Lambda works. Then I can define higher order function that we saw earlier and to pass the fun. And then I can just run it. Okay? So formally, the definition of Lambda, again, not in Java 8 or something, it's something general. It's anonymous function. Okay, just a function without a name, that's all. It's useful in order just to, if you want to make it fast, okay, to write fast code without defining functions and or names or classes, something like that. So you can just put this code inside. So as a common usage, we pass it as argument. And what is important to understand that in Java 8, it's only syntactic sugar. Okay, so it's nothing special. It's syntactic sugar for function reference. So in the runtime or compile time even, it's just the same. Okay. In some other languages, which is more functional languages, Lambda has more meaning. In Java 8, it's just syntactic sugar for reference, for function reference. Let's just see combined example. Okay, we have summary, which is public static function, left and right, summary, multiply the same, and we have some calculate, interesting, which accepts left and right, a B function, and just apply it. So calculate, do nothing but apply this argument to this function. Okay, what can I do with that? I can calculate 5 and 2 with sum. I can calculate 5 and 2 with multiply. And I calculate 5 and 2, and I can use Lambda here in order to define another behavior. For example, minus. Okay? Monad. It's just another term which is related to a functional. It is a kind of structure that represents computation. And in order to provide some meaning, we need to define to each block of this structure how this structure will behave. Very abstract, right? So let's see how in Java 8 is implemented. So in Java 8, stream is a monad. Okay, so it's simple to think about that. So let's see this example. Okay, so what we have here, okay, let's take a look closer. We have some menu, which is not defined here, but it's a collection of dishes, okay? Object dishes that has name and calories and something like that. And I can do like dot stream. So I get the stream from this collection, stream of dishes. What can I do with that? I can filter by some predicate. I can sort by calories. I can map, which is transform data from one to another. And I just can collect in order to get some result and do with it something afterwards. Okay? So this is a monad. Because it has a structure, okay? And I need to pass meaning for each of this block by some behavior. Okay? So how it actually works. We have menu. We start from menu. And then we do filtering. And we pass how to filter to this filtering. And then after the filtering, we do sort. And we pass the behavior how to sort. And then we map from dish to another form of data. So this form, get name, it's a string. So the new form of data is string. That's why we finally get a list of strings. And in order to collect it, in order to have some result from it, we need to collect two lists, and then we have the result. Okay? So this is the basic idea of streams in Java 8. Okay.
Question, when you say to get a result, you mean that the evaluation is a lazy evaluation?
Of course, yes. Okay. Yeah. So it's a good question. We have a lot of methods here, right? So the question is, if each time I call it, okay, something happened, or it's happened only here. So the answer is that only in collect method something really calculated. Okay, so it's lazy evaluation. A little bit definition: a stream represents a sequence of elements and supports different kinds of operations, like as we saw, and perform operation upon those elements. So it's like a collection, but not really collection. One important thing to understand here is that we have intermediate and terminal operations. Intermediate, we have just use it as a pipeline, okay? So do it intermediate, do something, do something, do something, and finally we have to terminate our calculation at this point. We actually say, okay, I'm finished, please calculate it. Okay? Let's see it again, just the same. So we see here that filter, sorted map, this is the intermediate operations. And finally, I have to finalize my calculation to say, okay, what I do with that, I collect. I can do another stuff like for each, yeah, just to traverse it.
Can you repeat the part about lazy implementation?
Yeah. So we see here that I use it as a pipeline, right? So we have a starting point of menu, then filter, then sort, then map, then collect. Okay. So in this code, if I remove this line, nothing will be happening.
The stream will remain as is?
Nothing will happen at all, okay? Because I didn't tell what to do, actually. I just configured my stream without doing nothing, okay? Only when I do terminal, final operation, it's a terminal operation, then something happens. So it allows to the implementation to do a lot of optimizations, right?
What distinguishes collect as a terminal function?
Excuse me?
What makes collect a terminal function?
It just defines terminal. Actually, the definition is if a function returns something that is not a stream, it's terminal. For example, a list, void, anything. Okay. If something returns stream, it actually means, okay, I can do something another on the stream and so on. Okay, it's pipeline. And another point to understand, streams versus code, because it reminds us collection, right? So it's something we have a lot of data, a lot of items, we want to do something, it reminds us, let's understand what's the difference. So yes, we do operation on sequence set of values. That's the same thing. The main difference is that collections are structured and they're about storing and accessing data, okay? So we can access sometimes in some specific position, right? And streams about computation, okay? I do not tell how to access the data, okay? I just want to tell, okay, please do it, okay? And I want to say how to do it, but I don't access the data, okay? So collection is about data and streams is about computation.
Streams are based on collections, the data.
Sorry?
The data for a stream is based on a collection.
Maybe it's maybe based on some events, and maybe based on file, okay? So different sources may be used for that, okay? A common example that you see it's collections, but you can imagine everything, okay? So till now we just went over some building blocks. Let's just summary it. We understood what is function reference, Lambda, which is like expression that came instead of function reference. We saw a little bit building blocks of Java, some function definitions of useful objects, and we saw what Stream API is, okay, which is a monad. Let's return to our basic question. Why functional? And we will focus on 3 items: less code, expressive code, correct code. And the rest 2 we will remain to later, okay? Let's start from this example. Please try to understand what this function does. Take a moment. Who is sure that he knows, understands what it does? Please raise your head. Okay, some people can do it with a few minutes, but most of us not, because it's you know to go inside the loops and so on. You can understand it, but you need to read a lot, especially when you're tired and it's 6 o'clock. So it's what it does. Okay, so let's see this example. I will not ask the question what it does because you don't. Maybe most of you don't understand exactly what map means and flat map and distinct. But let's look at this. Okay, we see something very clear. Okay. If I understand what map does, what flat map does, what distinct does, I just can read it, okay? So I explain it through this example, okay? So map, it actually maps every item, which is string, using this behavior. So this behavior says me, okay, please split your word by nothing. So it actually splits to a different characters, to all characters, okay? So this mapping actually returns me letters. Okay. Flat map means, okay, you have stream of streams. Please do it as a one single stream. So you have word. Word is a set of letters. So if we see like a stream of streams, which is the small stream, is the letters. Okay. So this is the hierarchy. So flat map is just flat all this to one, and we have the letters, okay, of all words. And distinct, as it said, it just removes or duplicates. So what we have just a stream of characters without duplications, right? And collect. It doesn't. I don't know exactly what meaning of what exactly this collection, but collect it means just give me the result, basically. Okay, so that's all. Okay, I just can read it. If I know the basic blocks, I can read it. I can understand it. So this is very expressive, very clean, and without bugs. Why without bugs? Because I rely on something that Java 8 implemented, right? I don't need to think about corner cases. Maybe I don't need to test it because it's very, very easy and straightforward. Okay? Maybe I need one single test, but I will not go to some corner cases for my tests. Yeah. Another concept is referential transparency. I would like to tell you some story. A few months ago, I went from my house. I just walked with my dog. You know, I just walking with my dog. Okay, everything is good, and I see a fire truck, one and another and one more. Strange, maybe some big fire. So I'm going to lazy with my dog. Okay, come back to my house and see the fire trucks near my house. And, wow, what happens? And I see the fireman just removes his equipment and everything is good. But I went to interesting. What is that? So trying to ask what is going on. He looked at me and said, "Are you Victor?" Yeah. Did you burn popcorn? Yes, it was 1 hour ago. So, and it's a big story, but why I'm telling you that? Because what I did is something small. I just burned my popcorn, just 1 minute more, and that's all. But I created some side effect. Okay, I created some side effect. So in reality, side effects just happens. We cannot influence on that, right? In our programs, we can. Okay, and when we remove side effects, we became more comfortable and more we control our programs better, right? We know what happens there. Okay, so referential transparency actually says that. Okay, or maybe in more simple words, pure function. Actually, referential transparency is more abstract term of the same thing. So pure function is more easy to understand. So by giving the same input, always provide the same output. Okay, so it's like a mathematical function, right? So we have a mapping, and it's a static. Nothing can influence on it. And execution of this function will not cause any observable side effect. Maybe something internally, but not observable. So if you burn your popcorn within, it will happen outside. No fire trucks. Okay, so this is the, yeah. Why it is so important First of all, because this mapping is static, it allows optimization by compiler. Okay, so if I already executed and computed my my result, and it goes again to the same place, I can just return the cache, right? Okay, so this is a very interesting optimization. Minimizes moving parts because this is a very self-contained function. Okay, it not depends on anything else. It is very easy to test. There is no dependency here, right? So it's very self-contained. I don't need to put dependencies inside. Okay? And of course, it decreases decoupling because again, it's very, very self-contained unit. Okay? And the other interesting question: is it enough? Okay. So we already see do it 1 and do it 2. Let's see it again. This function is pure function because it just takes some output, accepts some input, do computation, and return some output, right? Nothing, no dependency. This is pure function. It does the same, and again, it's pure function. But the difference is the way we do it. So here was imperative way, which is more bug-proven and less easy to understand, and this is very declarative. So in functional progressive, this is not enough. We also care about how we express our code, how we implement our code. Okay, we actually ended with some basics. We understood what function it is, basic term in Java 8, and so on. Let's try to go to some more practical examples and see how it works in action. Yeah.
Do it 1, it seems like it's time dependent. I mean, if word is shared, the state of words is shared between different threads.
Yeah.
In this case, crazy stuff can go. Is
Yep.
it the same when you're using streams? Or stream is duplicating the, let's say, making
Oh.
a copy of the words and then manipulate it?
Great question. So the question is like that. We have words here, okay? And I do manipulation here. I do a loop, right? So if this thread, if some thread have the same object of words, okay, and try to modify it, I will have some exception in best case. In other cases, I will do something. I will have something unpredictable, right? So it's not safe, okay. What happens in this example, because I create stream, it does not happen. Even more, stream itself is immutable data. Okay, you cannot change stream. What you can do, you can create new streams by these functions, and you collect or do some terminate, but you cannot modify it. Okay, so stream itself is immutable data. Okay.
Is it immutable or is it an atomic action?
Is it immutable?
Is it immutable or is stream?
Stream is immutable data.
It's not an atomic action.
What do you mean atomic action?
That the entire procedure needs to complete before anything else happens, like a transaction.
I don't understand the question. Try to express your question again.
An atomic.
Atomic. I don't think it's atomic.
What do you mean atomic? What do you mean atomic? What do you mean atomic? By what means that?
Atomic means that nothing else can happen whilst this is happening.
Within nothing else within this data, or nothing at all. What do you mean?
Other thread can run parallel to this one.
Of course, because
It's not. I don't think.
Why would you do that?
it's not an atomic in your program. No, of course not. Okay. It's not stops your program. Yeah, your program. Okay. Yeah.
Can you, instead of passing an empty string, pass a variable?
Excuse me.
Can you, instead of passing an empty string, pass a variable?
Instead of
Passing an empty string to the split function,
yeah,
pass a string variable.
yeah, you can do whatever you want.
But then it's not immutable.
Why?
Okay, so with string t, okay, but with different variables, like, I don't know, int stuff.
Ah, okay. You can do. Look, you can break it if you want. Okay, you can break things if you want. No problem. In Java, it's not a pure functional programming. Okay, it's not. So you can easily, if you want, you can break it. No.
It's not.
When will it evaluate?
Sorry.
When will it evaluate?
Evaluates only here, only in terminal. But still, you can break things. Okay.
Question is, you can solve it easily by putting final in the parameter of split. Is it not final?
By definition, it accepts only final things, Lambda, but it's still, you know, in Java, when you say final, it's good, but if it's a wrapper for something, you can still break it. So in Java, it's something that you not really safely define immutable objects. Okay, it's really depends on your implementation. There is no way to really protect it. This is Java. Okay. Okay. So our example will be to design a system that returns top UK and US music albums. Okay, this is our system. This is our first example. And I want to go to code. Here. By the way, if you will download the code, which is in GitHub, I published it. It is very easily mapped from this package names, okay, to the presentation that you have P, okay, P3, P2, and so on. So it's easy. I can jump it. You can also jump. So it's useful. Yeah. So first of all, I will, for this example, I define some album registry just in order to work with that. Right? So we have some albums here. And I will implement our system. So what we have here, we have some internal albums, okay, which represent all albums. And we have function that returns top UK and US by traversing it and filtering by UK chart, UKS, edits to the list and returns. Very simple, right? So what the problem here? The main problem here is that I use internal state. Okay, I use albums. In that specific case, it's a static. Maybe it's okay, but maybe it's not. Maybe it's used something an additional object and so on. So I have another moving part here. I have albums inside my object. Okay. So that's why top UK and US by definition is not functional. It's not final. It's not pure. I'm sorry. It's not pure function. Maybe in this specific case it's static, but maybe tomorrow I will decide to move this register to another place. Maybe it will be from database. So it's not pure function. So let's do the improvement. So version 2 says, okay, I remove the state outside. Now it's a pure function. Very easy, okay, very easy concept. But it's very powerful because when it's pure, we can do optimization, it's more clear, easy to test, and so on. The second level is to do it in more declarative way, okay? That's it. So let's go over it. I have albums, I create streams from it. I filter by hit albums, which is defined here, and collect it to list, okay? Same functionality in different way. Very beautiful, very compact, easy to see and understand it, okay? And using this functional reference, I can express what I do. I can actually document my code by naming my function. Okay, this is a very powerful thing for me. Okay? So, without going to the details of what hit album is, I can read it and understand. Okay, I stream, I filter by hit album, and I collect it to list. Okay, even without understanding deeply in Java 8, we can easily read it. Okay. Let's go over it again. So the first version we have inside our class we have albums, which is coupled. The second, we decouple this, okay? We have registry outside and we have top and UK function, which is pure. And we improved it even more by implementing declaratively, okay? Using streams. Okay, now we have, yes please.
And you could put a lambda instead of
Yeah.
a function.
Yeah, this can be replaced by Lambda, no problem. Yeah. I personally like more, Yes, I personally like more reference function because it's more expressive. Okay, you just can read it. When it's Lambda, you need to focus on it and to read the Lambda. And when you see Lambda with 4 lines, it's really became harder. Okay.
Reusability.
Lambda?
I'm saying this
Yes, yes, it's reusable, right.
Why wouldn't you go and implement predicate like you showed us before instead of the hit album?
Sorry, again?
Why are you not using predicate?
Actually, I do use. How I use it? Let's see it in the code. Okay, the filter. Okay, let's see a definition of filter. It accepts predicate, so I do use it, but I don't need to define a class that extends predicate. Compiler do it for me.
So you return a Boolean.
Yes.
Static that return a Boolean.
Yeah, this is the magic. This is the magic. Okay, so they define predicate. I use it, but I need to define new class and extend or anonymous class. It's code like that. I just define my function, and the compiler does the matching. Okay. And collect is more complicated because we have some collector. It's very complicated, but still, it's very hidden for me when I see the final code. Okay. Okay, now we want search albums by name and by year. Okay. This is next requirement. Here the search. Okay, so we learned about streams, right? So we dropped the idea of loops, and now we search by name and by year. Very nice, cool. Okay, search by name, stream, filter by name. By name is a function. By the way, here I defined it differently. I can define different ways. Okay. I define like by name returns predicate. And here is the predicate. I will return to this example and why I did it. Okay, for now it's not so important. But okay, I can do it. So we have by name, by year, very, very nice. The problem here, I see that I did the same stuff twice, right? So my code is duplicated here. What can I do here? I can pass my behavior. Instead of search by name or by year, I just go search by something, okay, by predicate. Here is albums, and please tell me how to search, okay? So I just use it, and I finish with that, okay? I don't have duplicated code. So passing behavior, it's a very powerful tool, okay? This is not something new in Java, but in Java 8, very easy to use. Okay, it's not something new, but it's very delicate to use. It's very compact to use. Okay, and then we can use it. This is the usage: search by predicate, album, and the usage very clear by name and search by predicate, blah blah blah. And the another thing we can notice here that the naming become too long. Search by predicate, and then please give me predicate. So we can. In this example, we can do small improvement, but this small improvement creates something more fluent. Search albums by name. This is the usage. Okay. So the naming is very important because naming is your documentation. When you name and you're short and you're expressive, finally you get this one. Okay. This is very easy to understand. Search albums by name. Okay. So it's a kind of DSL. DSL it's domain specific language. Okay, it becomes like DSL. Okay. So let's just come back to this. So we started from search by name and search by year, which is two functions. We duplicate what were not bad, and then we improved it by passing behavior. Okay, which is cool. And then we just make our name more compact, which created very, very nice example. Yes, please.
What does collector
collect.
To turn string into a
Okay, the question is what collect does, right? Okay, so collect is just transform stream. Actually, it gets a stream, okay, and collects it to another form. It may be a collection, it may be file, I don't know, but it's collect another form, okay. So it's final operation that after you do all your computation, you want to collect your data to any type of something, okay. So in this example, we will go forward, and the next requirement is get years of albums. Okay, we have albums, which is structure. We have years and names and something like that, right? So we only want to get years of the album. So we want the data in another way, another form. Okay. Okay. And we already know that we can use. Okay, here I use another feature of Java 8. On collection, we can do for each. Okay, this is not stream API. It's just another form of for. Okay, but it also gets some function, and we can do. Okay, let's start from hits, top UK and US, some function that does it. Okay, just filter by top and UK, and then we have result, and when we of the result for each hits, okay, please do this function. So this collects actually the from hit just the year to the list. Okay, so it's nice, right? So it's even better than regular for, but and it's nice. Okay, so but what we can do in Java 8 or in functional style, we can do something like that. Okay, you gave me my albums. I can filter by hit albums, and I can map. This is my main focus here. I can map, which is transform data of album, okay, to another form. This function actually does this. It transforms album to year, which is integer, and then I collect it. Okay. So the map actually transforms data from one form to another. Okay. Here the example. And we want the data reduced. Reduce, maybe you will hear some another term like fold. Okay. Let's understand, for example. We want to get the oldest album. So what the algorithm? We can go over each element, right, to save the oldest, and when we meet some element which is older, just replace the oldest. Right. This is the basic idea. Here is the implementation. We have 4. Let's go over all albums. This function tells me if left is older than the right. So if album older than current oldest, I just replace it. Yeah, very simple. Very we all know this. This is the other form we can do it. Just use reduce. What reduce does, it goes through the collection by pairs, okay, and the function that here should get two items and return one new item of the same type. So reduce just go over all the stream by pairs, okay, and each pair it has a result of the function that it defines, and go further with this result. Yeah. So using the reduce, we can implement logic like oldest or minimum, maximum, stuff like that when we want to traverse and do stuff like that. Okay. Let's do some summary. We understood what pure function versus non-pure. we saw a lot of examples of declarative versus imperative style. Okay. All the way we see that functions are our building blocks. We can move the functions, we can pass the function, we can return function. Okay, this is our new building block. Okay, and passing behavior versus static behavior, right? So instead of passing some parameter or define another method, we can just pass the behavior and use it inside our implementation. And we saw function refers versus Lambda. As I already say that Lambda is just synthetic sugar of function reference. So some will say that, okay, I like Lambda because it's very easy. Some will say, I want functional reference. It's okay. For me, it's more expressive, and it's more understandable when you use functional reference. Let's say more. Let's see more techniques. Interesting thing that we can do with this functional idea. Okay. We have a few things: execution guaranteed, builder pattern, composition, and currying, and partial application. Okay, let's start from this one. We want to guarantee correct locking, but write it once and let it use in multiple places. Okay. Sometimes in our program we want to create some infrastructure of locking, to think very hardly how I will lock, to design it and to provide to all other places in our code just to use it. I don't want each time to think how I will lock the object because very, very hard, right? So I can, if I think it again and again each time in my program, I will probably break my program sometimes, or it will create some spaghetti in my code. So I want to concentrate my logic of locking and think it once and just let it use. Okay. How can I use functional style with to implement this? Here's the code. Again, this is not something new idea, but it's very easy to use when you have functional reference and Lambda and so on. So you can do something like that. Execute safely. Please provide me the function. I will apply the function and wrap it with my lock. Okay. This is very simple example, but when the user will execute safely, he will not think or need to think about how to lock it. And I even switch the implementation of locking afterwards. Okay, I start with something simple, and I can to improve it later. Okay, so this is very, very powerful technique. Even if you don't use Java 8 or something like that, you can do it, and it is very good thing when you do something to wrap your logic. Yeah, it may be create stream and close it. Yeah, something like that. I want to show you. Okay. So the execution guarantee. Okay. Here's our code. So before Java 8, we can do it, but this is the code of user. Okay. It's not big deal, but it's not very, very clear because what I want is only this one. Okay. With Java 8, I can do it very smoothly. Okay. Builder pattern. Okay. Who feel that he knows what builder patterns very clear? Okay, nice. So I explain it. Let's see example. It's very easy to understand, and then I define it. So who knows or use string builder? String builder? Great. So string builder looks like that, right? We will use it. Append, 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 append. Great. And then I can do result, string to string, print, right? I will run it and keep talking. So what happens here? Here, I configured my builder, but nothing happened. Let's build string step by step. Okay. So it worked. I just configured my string builder step by step by doing append, 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 but nothing happened. Here something happened. Here is the calculation. Okay. So the builder patterns say that you actually there's a formal definition probably. No. So actually, it says that each intermediate operation, like in streams, just a part of your configuration, and it will return the same object type as you started with. Okay, so append returns builder string builder, and this returns string builder, but the state inside is changing. Okay, so we create this idea of pipeline, right? We create some pipeline, append, 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 and so on. Okay, so this is builder pattern. So we can and we see it a lot of examples, and stream API is based on builder pattern. Okay, because we do the same. We have stream dot filter. It returns some stream dot for each, or I don't know what. Okay, so it's just the same idea. So it actually creates what calls Fluent interface. Okay, it's very easy to understand. It's kind of DSL. Okay, it creates some Fluent interface and it's very easy to understand the meaning. Okay, so it's a very powerful thing, and we want not only to use it, we want to sometimes to create it. Okay, but and let's see example. In this example, we already saw it. We have search with predicate, right? But if I want to search for multiple predicates, and between predicates I want to say, okay, predicate and predicate and predicate, this is not enough, right? Because it's only one predicate. Actually, you want this one. Search, filter, filter, get all. Okay. This actually meets our requirements. We want to add more and more filters, and finally we want, okay, please give me all after your filtering. In order to achieve this, we can use builder pattern, and search actually returns the same type. Okay, so we can pipe it. Okay, so the filter return search albums with new state. Okay, so we just configure your object step by step. Okay, that's what creates so beautiful interface at the end. Okay, this is the idea. Yeah?
The all function is something.
Most of this code I created. Okay, this is the code that you can do.
In the all you added annotation override. So I wanted to know which evaluate I understand what you say. It's like the builder part, like the append, and the string is evaluated into a string, and the collect in the
yeah, it does the same. Yeah, and this all it does the same. Okay, this is the terminal function. Yeah.
It's your implementation.
Yeah, it's easy. You can download it, see it. Yeah. It's very easy to do. It's not something very complicated. Yeah, but it's a very good idea. Okay, it's a very interesting idea. Creates very clear and expressive code. Okay, it's very modular code. Okay. So we want actually this. Okay, this is actually the interface I created, what we saw, okay? So we do album search with filter that returns album search, okay? And then I provided all last, first, maybe it's useful because sometimes I want all elements last and first. By the way, last is not supported by Stream API in Java 8, which is very interesting to ask why. But I will not ask it right now. Another technique is a composition. The composition, it's like in mathematics. You can compose different functions. Okay, so if you have sum and square, which is defined here, you can do just apply with a summary, but you can create compose, which is sum dot and sum square. So the compose dot apply actually does this one. It's a square of 2 and 3. Okay, this is the composition. Okay, another concept is partial application. It's not so simple, but it's also important to understand. We have two. Again, let's understand through example. So let's look at this example. So we have simple add. Okay, we can define this like lambda a and b, a plus b, great. And we can define it in different way. We call it curried. Okay, and define it this way. So actually, it's a function that returns function. Okay. So the power of this technique is that, and here I can use it like in simple way, like apply as int, and the curried add apply dot apply as int. So this is not so different, right? The power of it is here. I can apply with 5, and I have a new function. And I call it add of 5. So I can use it. Okay? This is the power of carrying and partial application. But it is very mathematical example. Let's try to think where it comes to in our practice. Actually, we already know this function, right? It's search by album, by predicate. Okay. And now, let's imagine I have a function that I already created that match between album and the name. Okay. So it returns true if the name is the name of the album. Very simple. And I already have this function. So I want to reuse it. Okay, I want to reuse it. So I want to say something like that. Search albums. Please use this match already. I already implemented it. Okay, but the second argument, I know it. Okay, I know this argument, so it's something very static. Okay, so I want to create from match, which function that accepts 2 parameters, only 1 parameter. This is partial application. So 2 predicate. Match, and I just do the wall as a static one. Okay, nothing is changing here. Okay, this is what I want. Unfortunately, in Java 8, there is no way to make it to do it generically. So this is not Java 8. This is my implementation. Okay, it's very simple, but it's my implementation. Here is the implementation. I will not go to the deeper in the details, but this is not very easy. I need to think about it again and again, create such helpers. Okay. I will not go to the details why it happens, but this is the truth. This is the facts. Okay. And how can we do it different ways? So first of all, we can do it like that. Okay. We can, of course, do this helper that gets function that gets 2 inputs and actually transform it to new function, which is predicate. Okay. Don't try to understand it. It's not important, but it's possible to do. Okay. The other way to do it is just using Lambda. Okay. So here he wants predicate. Sorry. Yeah. Here the search accepts predicate, so I can create predicate, and I know that predicate accepts album, so I can write it album. Okay. Here I call match, and I pass the album, and here I say the wall. the name. Okay? So I implemented right now partial application using Lambda. Probably this is the most useful way to do it in Java 8, or to create some helpers. Okay? This is the two options. Okay? No natural way in language. Okay? But it's possible to do. A little bit trick, but it's possible. Okay? So you always can reuse your functions, okay, using partial application. Okay? Any question about this? Because it's not really easy concept. Okay. So again, we have much which already built. This is the interface we have, and we want to do to predicate, but it's not in Java. So we do it this way. Okay. Let's come back to our fundamental question: why functional? So we understood, okay, let's code. It's expressive code. It's correct code. It's fun. Okay. Why it's fun? I think it's for me when I started to think functional, and when you start coding, I felt like some satisfactory. Okay. I feel like, okay, I do better code. My code is better. My code is more decoupled. So it's kind of satisfactory. You understand, once you try it, you understand, okay, I do the right thing. That's the feeling that you have. So, and one guy from our team, when we moved to Java 8, which is, by the way, not a heavy process. It's very backward compatible, so it's maybe we'll encounter a few issues. It's really not a big issue. And he just, okay, I got it. He went to every place and instead loops, just throw out the loops. Okay, I'll write it the right way. So it was very exciting because it's really fun. It's really fun to think declaratively. Okay, you feel it's the right thing to do. And the next step, let's focus on performance. Okay, so
Can I
first,
you speak about fun, but to me it sounds like really difficult to debug.
okay,
But you have less bugs.
okay, maybe.
You just have less bugs.
From my experience from other languages, it's really difficult to debug this way.
Okay, so in order to, I accept it, okay, but it really depends on you. If you create functional reference and not Lambda, it's easier to debug, okay, because you actually don't want to debug Java 8. That's not your purpose. You want to debug your code. So if you create functions and use reference, you can easily debug it, no problem.
No, but if you have a flow that is based on a collection with 10,000 values that you got from somewhere,
Yeah.
and somewhere down the road an exception was thrown
Okay.
to probably maybe an input error, some data error.
Okay.
So it's very difficult when it's in normal Java.
Yeah.
Imperative, you can just put a break to catch the exact point where it was the exception was created.
You can do it.
In this syntax,
Yeah.
you get it as a block,
Yeah.
the filter, for example, and
Yeah.
it goes through all the values, and maybe somewhere in the map, for example, in a map,
Yeah.
somewhere due to the
But you can.
when
But
you got this exception,
but
it's very difficult to put.
you
into
can
the
put.
frame
Okay, let's see
frame.
it. Let's see it. You can. Here, right? The match. Yeah, good. You can put just breakpoint here.
Yeah, but then it will
So
stop.
you need to break it down.
But the problem is not in every, let's say you have 10,000 values.
Yeah.
The problem is somewhere in a bad value you just didn't think about
Uh-huh.
as a possible value.
Okay.
Somewhere in 555, okay? Well, if you put the breakpoint there, you don't get near 5, you just get the entire
Okay.
string.
What you will do in a imperative
I
way?
can make a conditional breakpoint for
Exactly.
No problem.
So make exception.
No problem.
exception
No problem. Do it here.
Exception break. Make
No
exception
problem.
break for
You
your-
can do mainly the same things, really. If you do right thing. If you do a lot of lambdas and your lambda is very complicated with a single line, you are right. So you need to use it smartly. Okay, that's why my preference is to use function reference and not lambda, because it's more easy to debug and it's understandable and so on. So it really depends on you. For me. Okay.
When
when you move from Java 7 to Java 8, didn't you struggle with a lot of static code being tested, can't be mocked easily? Isn't it something that you encountered during
No.
this transformation?
Not at all.
Transformation?
Not at all.
Can you repeat the question, please?
Okay.
Yes.
It-
Developers usually don't like static code because it's harder to mock, harder to test.
Okay.
And when you move to Java 8, I see a lot of static code.
It just, first of all, it's okay. The question is like that. We don't like static code, like static functions, because it's hard to test, right?
Harder to mock, yes. Harder to work with Spring framework.
Okay. So the answer is static code is only an examples. Okay. You don't have to use it like static code. If you prefer, for some reason, to do everything in Spring and singletons, you can do the same thing. Okay. It's just a little bit another syntax, but it's possible. No problem. So the static code is for easy to example. Okay. No other issues. So you can do instead of static. Okay. Let's do maybe some example. It's a main, but I can do something like that. I can remove the static. Okay. Can remove the static here. No problem. Just for example, here I don't need it. Okay. I'll do it like that. Let's go to the beginning. Yeah. So to predicate is static, right? Static reference. No, it's not a good example. Yeah, here. For example, this is static, right? But I can, instead of static, use object, okay, like this. It doesn't compile here, but the syntax is like that, so I can use object dot semicolons and use it, no problem. So it's just for examples. Okay. Performance. My question is, what do you think? Is it better in Java 8?
Should be in general, Java 7,
Yeah.
Java 8.
So there is no really answer to this question. Yeah, it depends, of course. Of course, it depends. So let's focus on some specific issues. Okay, pure functions may be memorized, what means that because it's a static mapping from input to output, I can use caching. Okay, and compiler on Java can use caching, so it may boost your performance. Stream API in some specific cases may behave a little bit. Okay, and we need to be aware of it. Okay. And of course, there's a lot of more consideration. I will not go over this big topic, and you will find a lot of discussions in the internet. But let's focus on some specific example. We already aware and know these very good functions, very beautiful functions. Do it 1, do it 4. Just remind you, this one is do it 1, and this is do it 2. And what I ask for you is try to think what is better. What do you think is better in performance? What is faster? Yeah. Who thinks that imperative is faster? Who thinks that declarative is faster? Okay, interesting. Okay, I run it, and you can download from my GitHub. I do it 100K times, 1K times, and I do warm-up, don't worry. So do it 1, it took 15 milliseconds, and do it 2, 63. Okay. Interesting. The main reason here is flat map, because flat map, it creates a lot of streams. Then I thought maybe I can improve it, and I proved my example. I still use flat map, but did some trick, doesn't matter, and I get better performance. It's 30 minutes, but still, okay. So I'm sure there are other examples that proves that streams are better, but I think it's very important to be aware of it, okay? Especially if it's a critical code or something like that. It doesn't mean you need to do pre-optimizations, but it's good to be aware of it, and sometimes it's very important for you to be very, very efficient, okay? You may pay attention to this. Yeah.
So, for performance, does the Java 8 provide parallel
Streams.
I
Yeah.
mean, you have a stream, you want to run it by parallel thread.
Yeah.
Is it possible?
Yeah.
I
Actually,
was expecting to see it.
yeah. Actually, I didn't touch this. Yeah, it will be faster, but okay, let's discuss a little bit. I didn't want to touch this topic, but yeah, there is parallel stream. I will show it. So we have stream, or we can use parallel stream, okay? Which the implementation just creates or use threads as number of cores, okay, in your server or computer, and does their computation in parallel. The interesting question, if you really want it, maybe it will be faster, maybe it's not, okay? But of course it will create a lot of overhead, right? You have new threads, okay? So you need to ask yourself if it's really worth it, okay? For example, in our application, we handle millions, or need to handle millions of requests per second, okay? And we do it already in parallel. So we have parallel users, a lot of users, which sends a lot of requests. So we already have this parallelism without any feature like that. So if I will use this technique, I will just create overhead, okay? Maybe it will be in some cases a little faster, which is I don't care about specific this small cases, but I will create more overhead and my CPU will work harder, which is very important for me. So it's very really it depends on your case. I think that this kind of feature is more it's tricky, and I think the most cases fall between you don't need it, and if you need it, maybe you need a lot of computers, servers, okay, and not do it in one server, okay. There are rare cases when you will use it, okay. So be aware of it, be careful with it. What does my say? Okay.
It's kind of an API question, but I would expect that there is parallel stream that I can provide it with some thread pool.
That's how they implement it. No, you cannot provide. No, I think that's good because they already do it pretty efficient. I think there are some issues because if you do some computation like that, and in another piece of code you use parallel streams, they will not in parallel. Okay, one computation will start it and finished, and then all the other will be performed. This is the implementation of Java 8, as I know. You can check it, but actually the parallel streams are not really parallel between them. Okay, which is fine. So be careful about this feature, okay? That's what I say. Okay, so we have improvement. Okay, so we are going to the end of the lecture. Can Java 8 be useful for functional programming? Why ask this question? Because you will see a lot of examples of or discussions in the web, which goes like, is Java 8 functional programming? Is it pure Java programming, functional programming, and so on? So I think it's not really important question. What is important here, can we use Java 8 for functional? Okay. Even more, can we use Java 7 or 6 for functional? Okay. My answer is yes. Okay. Of course, Java 8 simplifies, but most of the ideas we saw today, today you can use with Java 8, 7 or 8, no problem. Okay. It will a little bit more code, a little more effort, but you can use all these ideas. Okay. So in Java 8 we have functional refers, we have composition, we have Lambda, we have stream API, we have curried and partial application, but it's not really native, so we need to work a little harder, but you have a lot of tools here. Yes, please. Was it example? Lambda is a closure.
Not really. It's not true. So I think you still have finals there.
Yeah. Yeah, that's the difference. Yeah. The Java people call it closure. It's not really closure. This is the only thing we have in Java 8. This is closest to closure. Okay. So yes, the answer is yes. You can use Java 8. You can even use Java 7 and 5 even. No problem. Most of the concepts you can use with Java 8. Your work will be easier and natively. Okay. This is the question. Answer. Any problems with Java 8 when we think about functional programming? One of the problems is we have to define interface for function, okay? Like function with the generics or predicate and so on. This creates effort, right? So you need to create this effort. In some cases, you just want compiler to understand it. Why should I create this definition, okay? Okay. Special treatment for functions with primitives, because when you have function, I will show it. Okay, the function generic, so it cannot get primitive. Sometimes you want to be very efficient, right? So you cannot use it like this. So you have to define another function with special for primitives. That's what we have sometimes here. Okay, for example, int function. Okay, it accepts in, and then something like that. It's not native. Okay, you need to specifically create stuff like that. So it's creates a lot of some work to do. Okay. Partial application, as we saw, is not straightforward. Okay, you cannot do two predicate for function just like that. Okay, you need to create this utility, or you can use Lambda, but it's not natively in language. Some languages support this natively, and Java 8 is not. Typed exceptions. I don't have time to explain you this in examples, but in general, what happens when you have this Fluent Stream API, like here, okay? And just imagine here, we will use some function that throws an exception, and it is typed exception, so it will not compile. You need to try and catch. It can painful for the code, for how you can see it. So you need to create something. You need to try to catch, or maybe some utilities that will help you. It's not very easy, not very straightforward, and functions, the building block functions, which is already defined in Java 8, they cannot throw an exception. So if you want to use some function that's throw an exception, you cannot already define function in Java 8. Okay, so it's special treatment again because of typed exception. If Java 8 was supported only runtime, it was easier. Okay? This is the point. Okay, I want to finalize my presentation with some guidelines that I think it's very useful. So, first of all, aim to declarative. Okay, so try to be more declarative, less imperative. Okay, it creates clarity. Immutability. We understood that I didn't went through a lot of examples about that, but immutability creates easier code for concurrency. Okay. Aim to pure functions. We talked about that. It creates easy to test code, easy for concurrency code because there is no state. Okay, and also good for optimizations. Consider function reference over Lambda. I talked about that. So it's just easier to debug and to understand the function. It's my personal preference, but I really suggest it. And be aware of performance, especially when using streams. It doesn't mean don't use it, use it, but just, okay, be aware of it. And the last, maybe the most important thing, and I will just take a couple of minutes to talk about it. Actually, functional programming, it's not something new, right? It's very old idea, actually. It's a couple of decades and maybe more. So in the last few years, 5 years, it became very popular. Why? Okay, I think the most important reason, because people understood, okay, I have object-oriented programming, I have a concurrent paradigm, and I have more a lot of paradigms, and maybe I can help, maybe I can take a help from another paradigm and not be very paranoidic and be very, very pure functional programming, and to use only very, very pure functional languages, okay? So the languages like Java 8, like C# and more, or in Scala, of course, they support these paradigms together, and when you use it together, you create something, you can create something very, you actually have a lot of tools, okay? You have a lot of tools that you can work together. So you cannot, it's very hard to create program without state, right? It's a very beautiful idea. Let's do only functions without state, but you cannot, because you have to store some states in some place. So, for example, reactive programming or actors paradigms helps you, okay? And with conjunction with functional, you can create programs. You have more tools to create programs which is more clear, yeah, more debuggable and more correct, actually. So this is very. I think it's very important to understand. And a few words about LivePerson. So in LivePerson, we have a community of developers. Here you can come in online and check the possibilities. And here are some contacts with YouTube, Twitter, SlideShow, and so on. And we are hiring, not me especially, but and here is my code. I put it on GitHub, so you are welcome to download it, to try it. And you have a few minutes for last questions if you want.
You mentioned Scala.
Yeah.
This question is, did you consider, before going to Java 8, you considered Scala, and you had any comparison to say why you decided
Okay.
for Java?
Actually, specifically in our project, we didn't, because we don't have time to do it. Okay, it's a very running project. It's only in the production, so it would create a lot of overhead. But we still consider to take it, and we have a few projects, very big project even, which is written in Scala. Okay, so in company we do use Scala. Okay, here is a representative for Scala. He can talk a lot. Another question? What I want to say is that the move to Java, it's very, if you're afraid about it, because you know it's okay, new version and so on, it's very backend compatible. Maybe you will feel a few issues, maybe even not. Okay, and it's very easy. So I suggest to push and to move forward. Thank you very much.